Okay, folks, so now we are looking at logarithmic functions. Logarithmic functions, as with all functions, it's very important to be able to create the inverse in order to solve problems. So you should recall that to create the inverse, we interchange x and y. So if we had this y equals a to the x, that seems like an exponential function. Exponential. And then the inverse is found by solving x equals a to the y. All right, and this statement is equivalent to y equals log base a of x. I'm going to walk you through that. Now, a lot of times in pre-calculus, they try to memorize how to rewrite an exponential equation, but it never really clicked for me until I learned how to do the inverse operation. Okay, so let's start right here. X equals a to the y. Now I know that taking the log, if I take the log of both sides, and it really doesn't matter what base, so I'm just going to say ln because I can write 2 letters instead of 3. So I'm going to take the natural log of x, and I'll take the natural log of a, pen color, to the y power. Now there is a log property that allows me to drop the y in front. So then I now have natural log of x equals, the new step would be y, and then I have natural log a. And if I'm going to solve for y there, I would just divide by natural log a. So y equals natural log of a divided by natural log of x. I'm sorry, I wrote that back upside down, didn't I? Natural log of x divided by the natural log of a. And of course, the change of base formula allows us to say, if we have log and log, we can just write it as a single log of x with base a. All right, and that is exactly what we wrote up here. Now, if you don't understand all of that right now, you should pretty soon when we go through some of the logarithmic properties. But what I want you to start doing is memorizing this step. To get rid of an exponential function, we're going to take the log or the natural log of both sides. Okay, so this says to show your work to verify that the following are inverse functions. So that's exactly what we're going to do in the next 2 examples. So if y equals 2 to the x, that means that x equals 2 to the y. 2 to the y power. All right, and then ask yourself, what is the base? The base is 2. So log base 2, the exponent, log base 2 of x. So y equals log base 2 of x. The exponent here becomes y equals 0. All right, so let's try to, now it says to show work to verify. We didn't really show too much work, did we? All right, so maybe I was nervous I wasn't going to have enough room. So x equals 10 to the y. So we're going to natural log both sides. This is really the work that I should be showing. Drop the y in front. So maybe I'll write it as y natural log 10 equals natural log x. So I used the symmetric property of equality, which allowed me to switch those. I'm going to divide by log of 10. So natural log x divided by natural log 10. And that equals log base 10 of x. Now remember that if you wrote log base 10, you don't actually have to write that base 10. You can just write it as log of x. Okay? And lastly, y equals e to the x. If I have y equals e to the x, that's the same as x equals e to the y if I'm trying to find the inverse. Okay? So then we'll take the natural log of x and the natural log of e, and that's raised to the y power. Drop the y in front. Y times natural log e equals natural log x. And actually, this is one of those properties that that we're going to run into a lot. So if I wrote ln e, that's actually 1. So there's no need to divide by natural log e. I already have my answer. Y equals natural log x. All right. So that's that. And then since the graph of a logarithmic function is the reflection on y equals x, then we'll get the following. So this, on the left, is called an exponential, like a y equals a to the x power. But this one on the bottom, this is called a logarithmic function. Logarithmic. And it's going to be y equals, let's just say natural log x. Okay? I don't really know what base it has, but let's just stick with natural log x. All right. So that is your short video about logarithmic functions. Look for the follow-up video about logarithmic functions and how we apply algebraic properties to them to simplify expressions.